All right, now we're going to look at an inclined plane with friction involved. And we're going to do the same kind of thing we did without friction, but now we're going to add friction in and see how that changes our problem. And again, we're going to put that 15 kilogram mass on a 30-degree incline with a coefficient of friction of 0.1. And we're going to go ahead and find the acceleration down the incline. Now, if you didn't watch the first video without friction, I'd recommend watching it to get some of the backstory on why I'm doing some of these steps. Namely, why I'm choosing my acceleration and my axes like this. So my acceleration is down, and so I'm going to rotate my coordinate system. Also, that video is going to explain how to resolve mg into its components. All right, so let's go ahead and do that. So we are going to try and generate an equation, so we're going to need a free body diagram. So we're going to identify the forces acting on our block. So I do have mg. I do have a normal force, and remember normal means perpendicular to the surface. And there's also friction. All right, but my mg is not part of the x or y, so I will have to resolve it into components. So I have mg cosine of theta, because this angle right here is theta, the same as this angle here, and mg sine of theta right there. And we are going to redraw this just to make it a little more clear for us on what we are doing. So I have mg sine of theta trying to pull it down the incline. I have friction resisting that sliding. I have mg cosine of theta pushing it into the plane, and normal force is the force being supplied by the plane to support it. All right, next, I'm going to generate my equations from my free body diagram. So in my x direction, it is accelerating, it's sliding down that ramp. So I will be looking at ma. In the y direction, the sum of the forces is going to be 0 because it's not accelerating. And again, this is the coefficient of kinetic friction in this case. So in my x direction, I have mg sine theta minus the force of friction equals ma. Again, it's minus because it's in the negative direction. In the y, I have normal force minus mg cosine of theta equals 0. And if you remember from the friction video, whenever we see the force of friction, if we're not trying to find the force of friction or the force of friction is not given, we're going to substitute, substitute, substitute. So mu is given to us. That's not the force of friction, that's the coefficient of friction. So that means I'm going to have to make a substitution. So I have mg sine of theta minus mu times the normal force equals ma. Now again, I'm going to have to substitute in for normal force, and I'm going to find the normal force over here in my y direction. So I have normal force equals mg cosine of theta. All right, we're going to go ahead and substitute that in. So substitute, 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 right? mg sine theta minus mu mg cosine theta equals ma. And a keen eye would see that there's a common variable in all of my terms, and it's mass. And if it's in all my terms, I can cancel it out. And again, when I say term, I'm talking about things that are added or subtracted to one another. All right, so I get rid of mass. What does that mean for me? That means the acceleration is going to be the same whether this was a 15 kilogram mass or 30 kilogram mass. It doesn't matter. And again, we're just solving for a, so now we're just going to be plugging in our numbers. I can even factor out a g here because there's one on each term. And then I can have the sine of 30 minus 0.1 times the cosine of 30 will equal my acceleration. And we should get an acceleration of 4.1 meters per second squared. Now you did note if you watched the one without friction, we got 4.9, so our acceleration is a bit smaller with friction.